Question number 1 asks us to compare these two values to each other. How are we going to do that when we have no numbers in the triangle? Well, let's put in variable names for the side lengths of this triangle and just write an expression for the sine of angle A. See what we get. Sine is opposite over hypotenuse. From angle A's point of view, the opposite is y, the hypotenuse is z, so we get y over z. Cosine is adjacent over hypotenuse. From angle B's point of view, the adjacent is y and the hypotenuse is z. Look what we get. Identical expressions for both of these two trig expressions here. So whatever the numbers are, these have to be the same. Okay. Moving on to number 2. How does sine of B compare with cosine of angle B? Alright, let's do the same thing. Let's just put some variables in for the side lengths. And for sine of B, which is opposite over hypotenuse, opposite is x, hypotenuse is z. And for cosine of B, that's adjacent over hypotenuse. From angle B, the adjacent is y, the hypotenuse is z. Oh my, how are we going to compare these two expressions to each other? They sure don't look the same. I suppose this is probably not correct because they don't look the same. But how do we know if this is smaller than this or if this is bigger than that? Well, I blew right by a really important piece of information here. You might have noticed it, but maybe not, because I went right past it to the question. CB is greater than AC. This segment here, we are being told, is longer than this one. Y is larger than X. So since these fractions have the same denominator, okay, a larger numerator is going to make this a larger fraction. This fraction is smaller than that one. So sine of angle B has to be less than the cosine of angle B in this case. That makes this the correct choice. Moving on to number 3. Okay, got no picture at all for this one. And we don't really need a picture for this one, although I'll probably draw one. Which of these statements are true? Well, maybe more than one, so we better check them out one at a time. First statement here, sine of angle A, is that equal to sine of angle X? Without a picture, how can we tell? Well, if these triangles are similar to each other, okay, then A, being the first letter in that name, corresponds to X, so angle A corresponds to angle X, and if the triangles are similar, now I'll go ahead and draw a picture. A, B, C. We don't really need to do this, but if the triangles are similar and A and X correspond to each other, excuse me, there's my whole picture, then angle A must be congruent to angle X. The sides might all be different, but the matching angles have to be congruent. So this angle A and this angle X are the exact same size angle. So whatever it is, maybe 25 degrees, you don't have to look up in the table sine of 25 degrees twice to know you're going to see the same answer. Or punch in your calculator sine of 25 degrees twice to know you're going to get the same value. This has to be true. And then this statement over here, cosine of B, cosine of Y, well, the B corresponds to the Y. So that tells us, without even having to resort to the picture, angle B must be congruent to angle Y. And so the cosine of B has to be equal to the cosine of Y also, because angle B and angle Y are the same measure. So that's got to be true. How about this last statement, sine of C and sine of X? Well, back to the names. Angle C does not correspond to X. How does C compare to Z? I have no way of knowing. Or excuse me, how does C compare to X? I have no way of knowing. C matches up with Z. So C matches up with Z. But C and X, not likely to be the same size angle. Not likely. So this statement is not likely to be true. So 1 and 2 are true, making the correct answer choice A. Good luck on the homework.